Hi, welcome to my presentation of the Online Course Visualizer. This is a project that I've worked on for the past semester for my Educational Technology course. This course is part of my master's degree in Computer Science, Interactive Intelligence from the Georgia Institute of Technology. Before diving into the description of the tool, first consider the following scenario. For years, if not decades, education has taken place here. A room full of students, a teacher giving a lecture, and the process gets rinsed and repeated every year. With the rise of the internet and the blending of technology together with education, there has been a trend of taking this traditional educational experience and placing it online directly with no changes. This general online course experience involves students watching lectures, possibly of recorded in-classroom lectures, and then taking a multiple choice test. If the student passes, he moves on to the next set of lectures, but if the student does not pass, he is forced to go back and review lectures with little to no guidance or feedback. This type of online education described does not take full advantage of new technologies that may have been enabled by online platforms like massively open online courses or MOOCs. As an example, consider methods for providing intelligent feedback to students during assessments. Taking a traditional multiple choice quiz and only making it accessible online ignores the fact that educators could instead be providing real-time feedback, mix and match additional assessment methods, or analyze student inputs to determine where places in lectures may need to be refined. However, writing good, well-thought-out assessments and designing engaging and thought-provoking courses is incredibly difficult. A teacher needs to spend considerable time refining and crafting assessments and courses to help guide a student's learning. Therefore, enabling teachers to take advantage of the tools and processes available to them in online learning enables them to be more effective teachers and provides a better online experience to students in the end. Accomplishing this is not as easy as writing software and handing it to teachers. You cannot hand over to teachers the equivalent of a highly advanced space telescope and expect them to go and learn and in turn utilize every feature or functionality in a manner that is effective. Instead, educational technology should be developed to show educators how they are or are not using online platforms. For example, the use of specific platform features, providing students direct intelligent feedback, and the viewing the structure of online courses are all ways to help guide teachers to be more effective in online education. As such, I have set out to develop a visual representation for online course structure and content to drive intelligent feedback. The result of this is the Online Course Visualizer. Here are a few high-level points about the Online Course Visualizer tool I have developed over the past semester. First, with the focus on online courses, a web-based tool makes the most sense to ensure accessibility and alignment with online course delivery models. Second, I chose the edX platform as the basis for the content for my visualizations. The edX platform is an open source learning platform developed originally by MIT and Harvard in 2012. Because all the source code and development environments are freely and easily accessible, integration with edX made the most sense. Next, course content and analysis for specific types is something I wanted to achieve. My focus was primarily driven on problem set data, where intelligent feedback could be provided directly to students. Finally, rather than producing a static image, the visualizations needed to be interactive. Users should be able to show and hide items that they do not need to see at the time, and be able to drill down into areas where they're interested. The 4 images below detail the progression of the visualizations from prototype to final end product. At this point, I will now present the system architecture and conclude with a demo of the tool. First, starting at the top, edX course data is extracted from a running edX instance. The raw data is parsed, sanitized, and converted into a readable format. Then, the course is analyzed for specific features. This involves building the child-parent relationship of all the course components to build the visualization structure. Also at this step is where the courses themselves are analyzed. As an example, the tool will analyze the problem set text to see what intelligent feedback features were or were not utilized. As another example, the tool also connects to the YouTube API to query for the length of course videos. All of this analysis is then later presented in the visualizations themselves. Finally, the data is put into a data structure and placed into a generated HTML page that has already been formatted to include the necessary JavaScript libraries like jQuery and D3, as well as additional cascading style sheets that help form the themes and structure of the visualizations themselves. It is now time for a demo of the visualizations. Before I get there though, if you are interested in learning more or playing with the demos themselves, check out the website showcasing the visualizer at the link provided below. Alright, for this demo I'm going to be using the edX demonstration course content. You'll see that the root node starts out on the left, and then the first level of children nodes are expanded out. The parent node is fully expanded, it always shows up in orange, and child nodes show up in red. What I now plan to do is start to expand some of the content so you can start to see how the visualizations actually will dynamically change as different nodes are expanded and contracted. The visualizations are also interactive in the sense that they can be moved around, like you see here, and as well as zoomed in and zoomed out on to be able to drill down further on particular nodes. Now what I'll do is expand some of these final leaf nodes so you can see some of the feedback that you can provide with these visualizations. For example, you'll see that the videos, shown with the video icon at the top, if I hover the mouse over it, will actually provide details around the video length. This is some of the information that I gathered earlier and now producing as part of the visualizations. You can see down through the other icons some of the other types of course content, and then the ones with the square and the pencils are problem sets. In this case, that one didn't have any unique features, but this one here does. It actually takes advantage of some of the features of the edX platform. Thank you very much for watching this demonstration. Once again, the URL for the Showcase website, along with the demos and source code, is provided in the link below. Thanks again.